Hello again. Today I'm going to talk a little bit about tuning forks. This is a homemade one. You can see it's just made out of aluminum. And if I tap it, see, it makes a very pure sine wave, and we can see that with our scope. I don't have a microphone, so we're just going to be using the speaker. See, the frequency is roughly 2.6 kilohertz. See, it doesn't take much to set it off. So if I take this little piece of rubber, I'm just going to put this over the end of one fork. See, that completely dampens it. And it doesn't matter which end I put it over. You could put it over two. So if you're old enough, you may be familiar with one of these. This is called a Vibroplex. This is a semi-automatic keyer that you would use for sending Morse code. You can see there's a weight in the back, and this is attached to this long rod that connects to this reed. So you can see there's a hand piece here that you can move left and right, and there's a hard stop down here, and then there's two hard stops on the far side, and then there's a small reed, and this thing will actually vibrate on this. And there's another small spring here that's actually another switch contact. And then there's this dampening assembly here. So as I move this thing, you can see it kind of vibrates. Here I have my Unity UT90A. This has a very fast continuity test. What we can do is just attach this right across the switch contacts. So again, the weight here will control the speed of this switch. So as I move this thing towards the back, it's going to get slower. And as I bring it closer to the reed, it's going to speed up. You can see this arm over here basically acts as the dead stop for the reed. So I wonder if we could think of another use for a tuning fork when it comes to testing these multimeters. Here's another possibility. We could maybe use it as a set of artificial fingers that could grab the selector switch and rotate the knob through its different positions. You can see I just have some software here that's written in LabVIEW, and that little tablet is controlling the stepper motor. And with everything kind of floating, basically we don't put the switch in any sort of a bind. Alright, so we put 2,000 cycles on this switch. Now, of course, this is the meter that we've damaged, and then we drop tested it. So this is not by any means a brand new meter. Plus we had damaged the switch contacts from our transient testing. But some of the switch contacts should still be in pretty good shape. I think we're going to get a pretty good idea of what this does to it. You can see after even 2,000 cycles, very little wear. So why run a test like this? Well, I've seen some meters in the past where the contacts wore very quickly. just in the short time that I was doing my evaluation, I could actually see metal flakes ending up between the switch contacts. And that was far less than 2,000 cycles. So now I'm kind of curious how some of these cheap meter switches hold up. And again, these are not in the best of shape. You can see I had replaced this contact here. That's why it's a little clearer. The rest of these have had a fair amount of current flowing through them. Let's just put this meter back together and we'll continue to cycle test it. This is the cycle count. You can see we just passed 1,000 cycles. The batteries in the camera had just failed. So this is in addition to the 2,000 cycles we've already placed on the switch. See, we just passed 2,000 cycles. Gives us a little over 4,000 cycles on that switch now. Alright, you can see we're at 3,700 cycles, and that's in addition to the 2,000 cycles that the meter's already seen. So why so many cycles? I guess, you know, if you use the meter, let's say 260 days out of the year, and you cycled it twice per day, and then you own the meter for 10 years, that would be equivalent of 5,200 cycles. Yeah, I wouldn't say that 6,000 cycles would be unreasonable for a meter to pass. Let's go ahead and shut this thing off and we'll take it back apart and let's see what it looks like. Still looks pretty good. I don't really see any wear marks or anything in this switch. You know, some grooves being cut into the board, but it doesn't look like it's wearing away at the plating at all. And the contacts themselves look quite good as well. Yeah, so maybe in the future we'll use this test fixture to evaluate some of the other meters. Well, I think that's going to be all for this video. Hope you found it interesting. Till the next video later on.